The next speaker will be Marcel Claessen. I already mentioned that he is in the stage of leaving us, unfortunately. Marcel has been working for years for the Netherlands Institute of Ecology. He is a plant-animal interaction person, and we thought that a story about birds and what birds do to aquatic ecosystems could not be missed in this conference. So that's why we asked you, Marcel, to participate in this. And well, I really appreciate that you have come back. Actually, you had already moved, but now you are back for just a few weeks or so, maybe 1 or 2 weeks, 1 week. And well, we certainly enjoy your talk, I'm sure. So, what's the role of birds? That's the title of your talk, and we would like to give you the floor.
Thanks, Jos. Thank you too for inviting me. It's really an honor, a great honor, to be speaking in such a for such a fine audience and with such great other speakers. Yeah, so I changed the title a little bit earlier on this morning. My topic was a little bit different, but I thought, well, what I first should do is try to convince you that birds do play a role in aquatic ecosystems. So I would like to start with that, and then after that turn to how does this work? Yeah, and after that work on or address the issue, how will climate change change these birds and their role in aquatic ecosystems. But first, the role of birds. Well, most of the people, they do appreciate birds for how they look like. I think they're splendid creatures, and you've seen them feature in the poems by Brian, that Brian showed you. But otherwise, that they do play a role in aquatic systems, besides being just nice and being there, you don't hear a lot of it. Eric mentioned coots briefly in his talk, but otherwise not in any of the talks that we've heard this far. And that's not an exception, because also if you look in the textbooks, there's very little you can find on birds there. For instance, in this relatively recent textbook by Christoph Brunmark and Lasanders Hansson, it's just out of the 200 pages that are in this book, it's just a quarter page on birds. And it doesn't say much more than, yes, they are also there, period. If you would ask the ordinary public, and notably farmers and anglers and fishermen, they would say, oh, but birds, they do play a role. They are a big nuisance for farmers, and anglers rather have that big fish on their hook than in the beak of this cormorant. And indeed, these anglers and fishermen have resulted in the fact that now, about a year ago, there is a new cormorant management plan, a European-wide cormorant management plan in the making. What this picture also shows, and that is something that I think we should realize as ecologists, is that these birds, they do eat large prey. Maybe not the size that you see here. I think this cormorant must have had a hard time, but they do eat relatively large prey, and in that sense, they already play a special role in aquatic ecosystems, I think. But there's more to mention about birds. In aquatic ecology, it's much about nutrients. I think I don't have to convince you about this after the first three speakers. It's much about nitrogen and phosphorus. But when dealing, and there are multiple textbooks where you can see this point being defended. And not only when dealing with aquatic systems, also in terrestrial systems. So the populations of animals, they are limited by the availability of nutrients. And I think that's a very fair case to make. But once we, for instance, have grown big, the need for nitrogen isn't that high, really. And I think there is, I mean, as a vegetarian, you can live very well once you have grown into adulthood. Because what we need is carbon. We need to keep the stove burning. If you would have looked at the you all made your way here in very cold conditions, and maybe your thoughts drifted towards the Arctic and the Antarctic explorers. If you would look at what they took along, their diet mainly consisted out of butter, a bit of pemmican, and otherwise just butter, because they need the carbon to keep the stove burning. Now, we may be hot, but birds are even hotter. They are about, on average, 3 degrees hotter than that we are. And that means that when they don't lay in bed, we lay in bed. If we lay in bed, we have our basal metabolism, but when birds sit on their perch or just with their heads tucked between the feather or floating on the surface of a lake, then they need a certain amount of energy. It's called the basal metabolism. And so it's here. And it is, for birds, it's quite higher than for mammals. This is a logarithmic scale, so you don't, the difference look minute, but this little difference in temperature makes a whole lot of more energy being spent. And for reptiles of say 20 degrees, it's 2 orders of magnitude. And indeed for fishes of similar size to birds, in Dutch lakes and ponds and ditches, the metabolism will be about 100-fold lower than of the bird floating on top of that water of similar size. So huge differences in metabolism. And this is a Buick swan foraging on fennel pondweed. And what I want to illustrate with this is that for aquatic foraging animals, the energy that they get out of the system may be really high, much more than in terrestrial systems. Now we wait until this movie is finished. So here you see the Buick swan going for the tubers of this fennel pondweed. They're not that interested in the above ground biomass. Yeah, I can stop and go on. And what we did, with the help of a lot of people, we looked at the intake, and then here in terms of energy again, of these tubers at various places. So this is in Russia, in northern Russia. This is in the breeding area of these Buick swans. And this is here in our own Lauwersmeer in 2 different years. And this is in the White Sea. But we not only looked at how much energy they ingest when in aquatic systems foraging on these tubers of fennel pondweed, but also on agricultural fields. So this is on harvest remains of sugar beets, and this is on grass fields. And what you see is that on average, when they are foraging aquatically, they attain much higher intake rates than they do on beet fields. So though this is really also just a feeding frenzy. There's food, plenty of food on the field, but still they don't ingest as much as they ordinarily do in aquatic habitats. And these measurements are mainly made during periods of high energy demand, so when they are on migration, for instance. Now, why is this? It is actually mainly because the time they can spend foraging in aquatic habitats is just simply 24 hours a day. And these guys here on the Korovinskaya Bay, preparing for their long journey, their 4,000 kilometers journey to here, they were eating close to 90% of the 24-hour daylight period. And it's just because this environment, the aquatic environment, is a very safe place to be. Birds like to be there because it's just safe. Foxes don't get there, and you can eat there day around. So besides being hot, they also eat a lot. And then, of course, we have the fish eaters. The cormorants have been mentioned already. And now if you would just look at what the cormorants in the Netherlands, so we have about 20,000 breeding pairs, and we would only focus on those 20,000 breeding pairs. What they eat is indeed a huge amount of fish. It's 10,000 tons of fish annually. Now this is a calculation made on the back of an envelope, just departing from what the expected energy requirements for cormorants would be, and then you derive at these values, which I think are really in the order of where it gets to. Now on top of that, so because 10,000 tons of fish, of course, in the Dutch waters, there's much more fish than that. But then taking into account that they select, they they select certain fish, and also that you don't find them uniformly distributed over the country, but of course they concentrate in areas where they are left at peace and where they can also breed. You do get quite local effects of these cormorants, so you may expect those effects to exist. Lake Veluwe. Here we have a success story of how water management has improved water quality in the Netherlands and therewith also aquatic vegetations. But with the development of these aquatic vegetations also came the water birds. And they are doing very well, the mute swans. And if you look at how the numbers have developed over the past years, you actually now derive at the biomass of mute swans on Lake Veluwe, which equals the biomass of the fish that are living in there. If you then consider that their requirements for energy are at least 100-fold of the fish that are there, I mean, you can't neglect them. They are main players in systems like Lake Veluwe. And on top of that, it's not that they need so much energy, it's also they can go for other types of food. And that is, again, related to their quest for carbon rather than their quest for nitrogen and phosphorus, where a lot of other organisms like daphnids and algae are much more dependent on than the hot birds, because again they go for the carbon. And what would that mean in their diet selection? Well, they can do with poorer diet of a poorer quality. They can deal with diets that are relatively rich in carbon compared to nitrogen and phosphorus. And if you imagine a daphnid that wants to produce eggs, it needs algae that are relatively rich in nitrogen and phosphorus, and not so much in carbon. But water birds might, for instance, do with plants that are much higher in carbon content. And Bartnett and I worked on this issue, so this was a nice concept, but does it also help true? And what we did, we looked in the literature for data on the maintenance nitrogen requirement of animals. So how much nitrogen do you require to just stay in balance? And then what is your basal metabolic rate? So actually your carbon requirements, and that's the ratio between the two, and it's plotted here for various animals. So for cold-blooded reptiles, somewhat warmer marsupials, eutherian mammals, they are again a little bit warmer, and then the birds, which are indeed quite hot. And you see that if you plot the ratio of these two, then the birds end up a little bit in the lower part of this panel, and then you go for the mammals, which are a little bit higher, and then the reptiles are high up here. Now, what does this mean in terms of carbon and nitrogen? Oh. So that's plotted on this axis. So that's then the gross nitrogen to carbon ratio, and with gross, so this is what you would want plants to contain in order for these animals to have a balanced diet. And you see that the nitrogen to carbon ratio of the plant material that birds would require is quite much lower than that of, for instance, the reptiles. And the fish would also end up in this range. So this means that these birds can do with types of food that are much lower in quality than other animals would require, cold-blooded animals would require. So the position of these birds in aquatic systems is quite different. They go for other types of food, and they do require a lot. So please don't consider them in terms of biomass, because the biomass that they represent does not represent their impact on the system. So they're beautiful, they go for large prey, they need a lot, and on top of that, what they need can be of a relatively low quality. So they can be relatively rich in carbon. Now another aspect of birds is that they fly. They have wings, and they migrate over long distances. So these are snow geese, and they go from central US to the north to breed in the Arctic. But also here in our part of the world, of course, we know all about our geese and ducks. Most of the water birds that we have here in the Netherlands are actually breeding in the high Arctic. Now, birds can carry a lot of things with them. This is an exceptional case, of course, but there are other things that they can also transport, and that is, of course, water plants. They can take seeds on their feet, between their feathers, but also seeds may survive a passage to the intestinal tract. And actually, a lot of water plants, their viability increases after passing through the digestive tract of water birds. But besides water plants, they may also carry invertebrates, even snails. Snails may survive the passage of a digestive tract. Not all of them, but some snails seem to be adapted to this. And of course viruses, which is at the moment a big scare. We don't talk about that today. But they do function as carriers of propagules of a wide range of organisms, and in that way connect wetlands. So that's also an important role. And besides carrying other organisms, they may also carry a lot of poo in their belly. And notably herbivorous birds, because they need to eat a lot to satisfy their energy needs. And this also defecate a lot. And it has been proposed a lot of time in the literature that they have a role in this, but how much it is, that has little been done really. And so these are still valid questions. And what we did is we made models, also again actually on the back of an envelope, using the energy requirements of animals and some mathematical descriptions of how the digestive system works, to make calculations on how much energy, for instance, herbivores, geese that forage here on agricultural lands, would transport to freshwater bodies. And we did the same for carnivorous birds. So I don't go into details on the model, just the results. So what we did is we took data from SOFOM, which are data on how many birds are around at any given time of the year, and made some calculations for different years. And you see that birds may take quite dramatic amounts of nutrients. So we did this not only for nitrogen but also for phosphorus. But they may take quite large amounts of nutrients into freshwater bodies. But then if you divide it by the total area of freshwater that we have, it is again a very low figure. And the same for the carnivorous birds. Those figures are not exceptionally high if you consider the entire surface that we have. Notably not if you compare it with what farmers put on their land and how much excess nutrients, so nutrients that don't end up in crop, actually go back into the surface waters. But locally, there might be huge effects. And of course, we all know, or at least those that go outside and look birds every now and then, know that geese may have their preferred roosting sites to spend the night. They don't just spread out evenly over all the aquatics, all our wetlands that we have. Now and then, I think this is the final aspect that I would like to mention. That is the effects of foraging and bioturbation. And again, I take the Bukes one here as an example, but you can replace it by many other water birds, because the nutrient cycling increases. So in plants there are a lot of nutrients, and when it's eaten, it is quickly released again into the water, because again these ones they only grow when they're young. Of course they need some nutrients to produce feathers, but otherwise the nutrients, they go in and they go out again, and they become readily available for notably algae, because the nutrients will be dissolved in the water and are taken up much more easily by algae than they are being taken up by macrophytes. And of course, this trampling, you have seen that in this picture, increases turbidity. So in that sense, they don't really favor the macrophytes. Okay, so I hope I have convinced you that these water birds deserve to be considered when discussing the status of water bodies and where it may go in the future. And now to climate change. So how will these birds and their effects on the systems be affected by climate change? Well, this is quite a challenge to say anything general about where it will go with our water birds. First of all, we should realize that it is already very difficult to say something about what will happen to algae and daphnids and fish. And these animals, so the water birds, they are functioning at a much higher trophic level. So everything that happens at lower trophic levels should be integrated into this higher trophic level. So it will be increasingly difficult to say something about where it will go, because uncertainty is enormous. And especially because all the organisms, communities where they depend on, they don't all respond simultaneously in the same fashion. So the directions of these interactions may be hopelessly complicated. On top of that, the behavior of these animals can be quite complex. And some novel behavior might suddenly appear. As an example, we take the pink-footed geese. Pink-footed geese, they breed on Spitsbergen or Svalbard, and they use the winter in the Netherlands exclusively. The entire population migrated from Svalbard over here to spend the winter here. And it was the winter of Reinier Paping. That was the first occasion that they were pushed out of the Netherlands. Too much snow, they couldn't get to the grass, so they moved southwards and they discovered Belgium. Something makes me think about a song of Doe maar. Reinier Paping, so that winter caused them to discover Belgium. And then in the late 70s, there was one very severe winter, 78, 79. And then, of course, we had the winters of Evert van Bentum. And after that, these pink-footed geese, kleine rietgansen, they completely had it with the Netherlands. And from then onwards, they came to the Netherlands just briefly in October, and then afterwards went to Belgium and stayed there. Because they discovered also in mild winters, it's a very good place to be. And this happens a lot, that they discover that they just change their behavior. They are very flexible. Another issue is that they are living, their world is large. We are discussing huge spatial scales here. I already mentioned that Buicks once may migrate 4,000 kilometers from northern Russia to here, but there are birds that are coming, like the brand geese, they come from Taimyr all the way to here. So they migrate over large spatial scales. And the problem is that in relation to climate change, that suitable habitats are not uniformly distributed. So to make the point here, we go to tufted ducks. This is just describing their wintering distributions. So the red dots, that's where they go. They breed in this bluish area, that's where they breed. And they go to warmer areas where there's a high chance of open water throughout the winter during the winter time. Now, if you imagine climate change, and you would just say, well, this whole isotherm, this 0 degrees January isotherm just moves up a little bit to the north or to the northeast, and the birds will just move with it. Well, that would be the case in a uniform world. But the world isn't uniform. And the places where they want to stay, they aren't only determined by the temperature, but there should be other features around, like open water, for instance. And that, of course, also holds for their breeding area. You can say, well, it goes further north, but then they will end up ultimately in the Barents Sea. Well, this is not a big problem for tufted ducks. But for other high Arctic breeders, it is. And then another point is that climate change, and the introductory slides by Jos illustrated this, climate change doesn't have the same effect on all areas on the globe in a similar fashion. You have differences between areas. And to illustrate that here's an overview of the changes in the onset of spring, which is based on NDVI data, in Northern Europe. And you see here that over this period of time, and this has continued afterwards, that spring is advanced in Denmark and southern Sweden, and delayed in this part of the world. And you may think, how can that come about? Because it becomes warmer everywhere, but we also learned that precipitation increases. And in these areas, you do have more snow cover, and it takes a longer time for the snow to disappear. So that's why the spring there is actually delayed. Not so much because the temperature drops. Now it isn't dropping, the temperature is also increasing there, but because of the increased precipitation in the form of snow. Now, and how have the geese reacted to this? Now in Denmark, where the spring has advanced, they leave earlier. And this is all data from Jesper Madsen, a colleague from Erik, so also from the NERI. So they leave earlier. And they have discovered Trøndelag, so mid-Norway. So here you see, well, the average is 4 days, but in fact there the sample size is really low, because a lot of birds didn't even care about mid-Norway. But it's also an area, just like Belgium, that they discovered, and they started to use. And it is increasing, also over the past decades, it's steadily increasing. So you have, again here, an example of novel behavior, but also behavior that changes in response to a change in climate, and a rapid response. The behavior evolves not due to natural selection now, birds just start doing different things. And the other point that makes it very complicated to make predictions is that there are many other processes going on. And to illustrate that, we again turn to the pink-footed geese. Their numbers have increased quite dramatically over the past few decades. And it's mainly due to agricultural developments here, where we get to come to an example of that a little bit later. And now how would we predict that to go on from here? Well, if you look at the breeding grounds. So here in red, this is the suitable area on Spitsbergen that is available to these birds. And with a 1 degree Celsius increase, that area would only grow. And when it's 2 degrees, it won't only grow even further. And we have already heard that it might go up to 4 degrees. So the potential area where they can breed only becomes bigger. But this is not the only thing that counts in these migrants. What about their stopover sites and their wintering sites? Now let's start with the wintering sites. This is where they winter. And this is how it may change. Because that is not so much, I'm almost finished. This is not so much related to temperature changes, but how we are going to manage our agricultural fields. There's a lot of talk about making biofuel. So, and biofuel, that's no good food for these geese. And it will change the area that is available, the potential areas where they could grow into, only smaller. So that's the brown specks here. Those are the areas that will become unsuitable. And actually the area for the geese will become smaller over time. And then there are yet other processes that we should take into account, and that is how we ourselves think and perceive these birds. And the love for birds has only increased, and people have started making research, and this is an example for the population developments for barnacle geese. So people have stopped hunting, and we don't think much about of hunters generally. And we make research, and the populations only react, or seemingly react, to all these developments. So this is the last slide. And actually, I think that if we want to know more about how the developments of these waterfall and other water birds will go into the future, I don't think that climate change is the main thing to worry about. It's mainly the global change processes that have a paramount effect. And here in the Netherlands, we have to realize that we have just one big trough of food for a lot of water birds. They like the water, but they like even better the agricultural fields. And populations will probably only continue to increase. And we have to make a decision how we want to manage our zoo. But on the other, there are also developments that go into a much different direction. And I'm not talking waterfall here, but mainly waders, which are on decline worldwide because of major things happening in not so much Europe, but although in the Wadden Sea things happening too, but also other parts of the world. If we think about what's happening in Asia right now, where large estuaries are being dammed and destroyed, leading to population declines in some Australian waders, which have gone down by 80% over the past 5 years. This is really something to worry about and should have more our attention than the climate change. But then only when we are discussing birds, I think. And I would like to leave with that.
Thank you very much.
Thank you.